50,000 years ago, a hunter woke before sunrise and glanced at the sky to plan the entire day. No clock existed, no calendar hung on a wall, no phone buzzed with a reminder. Yet this hunter knew the season, tracked the moon, and predicted weather patterns days in advance. How did early humans manage time without a single tool we depend on today? This video breaks down the full system our ancestors built to measure days, months, and years, using nothing but the sky, the land, and their own bodies. Picture the Paleolithic era, tens of thousands of years before writing existed. Small bands of Homo sapiens moved across open plains and river valleys, following herds and hunting seasons. Daily survival depended on precise timing. No margin existed for guesswork. A group hunting at the wrong moment starved. A group planting or gathering at the wrong point in the season lost months of food. Every decision, from where to camp to when to travel, rested on a working sense of time built without a single written number. Early humans built a working calendar without numbers, without written language, and without any single person holding the full picture in their head. Archaeologists found bones carved with a series of notches dating back over 20,000 years, and researchers believe these notches tracked lunar cycles. The Lebombo bone, discovered in southern Africa and dated to roughly 44,000 years old, holds 29 notches, matching the number of days in a lunar month almost exactly. The Ishango bone, found near the border of Congo and Uganda and dated to around 20,000 years old, holds a similar pattern of grouped marks many scientists read as an early lunar record. Two bones, found thousands of miles apart, both point toward the same conclusion. Early humans watched the moon closely enough to count. Reason one behind this system comes down to survival math. Hunting depended heavily on animal migration, and migration follows season changes tied directly to the position of the sun. A band tracking the sun's path across the horizon predicted when herds would return, when rivers would flood, and when plants would bear fruit. Miss this pattern by even a few weeks and starvation followed. Modern comparison helps here. Think about checking a weather app before planning a weekend trip. Early humans ran this same mental process, except the weather app lived entirely in their memory, built from years watching the same patterns repeat. A single missed cue, one warm spell mistaken for the start of spring, meant weeks of wasted effort chasing herds already gone. Reason 2 adds a social layer to this survival math. Tribes needed shared timing to gather for hunts, trade, and ceremonies. A single hunter tracking the moon alone helps nobody. A whole group agreeing on a shared count of days allows coordinated action. Oral tradition carried this shared count forward. Elders passed down knowledge of seasonal markers, star positions, and animal behavior through stories, songs, and repeated demonstration. This transfer of knowledge functioned as a living calendar, updated and corrected across generations, passed from elder to child long before a single word of this knowledge reached a page. Compare this system to modern timekeeping, and the difference becomes obvious fast. Today, a phone tells you the exact second, the date, and the weather forecast for the coming week. Early humans held no fixed reference point, no written record beyond a few carved bones, and no way to correct errors quickly. Yet their system worked well enough to guide survival across tens of thousands of years, proving accuracy mattered less than consistency and shared understanding within a group. A modern person dropped into this world with a working phone would still struggle without the accumulated pattern knowledge held by an entire community. Here comes a detail surprising most people. Many assume ancient humans held no concept of counting beyond simple tally marks. Research on the Ishango bone challenges this assumption directly. Some mathematicians argue the pattern of notches shows early multiplication and even a basic understanding of prime numbers, since several groups of marks cluster around numbers like 11, 13, 17, and 19. This claim remains debated among researchers, yet the mere possibility flips a common myth completely. Early humans potentially built mathematical thinking into their timekeeping system long before formal math existed anywhere on record. Now let's break down the full system piece by piece, starting with the most basic unit of time these communities depended on. The sun gave early humans their first and most reliable clock. Sunrise marked the start of activity. Sunset marked rest. Shadows cast by trees, rocks, and eventually deliberate markers allowed rough tracking of hours within a single day. Some communities placed stones or sticks in fixed positions and watched shadow length change through the day, creating an early version of a sundial long before Egypt built the famous stone versions we associate with ancient timekeeping. The moon offered the next layer of structure. A lunar cycle runs close to 29.5 days, and this predictable pattern gave early humans a natural unit longer than a single day but shorter than a full year. Hunter-gatherer groups likely used the moon to plan gatherings, migrations, and rest periods. The carved bones mentioned earlier support this theory directly, showing repeated counts aligning with lunar phases rather than random marks. A month, in this sense, existed long before anyone wrote the word down. Seasons formed the next major layer of this system. Early humans watched temperature shifts, plant growth, animal behavior, and day length to identify four rough periods across a year. Cold periods signaled a need to store food and seek shelter. Warm periods signaled planting, hunting, and travel. This seasonal awareness required years of pattern recognition passed down through direct observation and oral teaching, since no written record existed to speed up the learning curve for each new generation. Stars added another dependable layer once humans began traveling greater distances and needed navigation alongside basic timekeeping. Certain star clusters appear only during specific seasons, and early humans used these fixed points to confirm seasonal timing and guide long journeys across unfamiliar land. Star patterns worked as a backup system when weather blocked a clear view of the sun or moon. A cloudy week often hid the moon for days, and a reliable star pattern kept a whole group oriented until clearer skies returned. Large stone structures built thousands of years later show how far this skywatching eventually reached. Stonehenge, built in stages starting around 5,000 years ago, lines up with the sunrise on the summer solstice and the sunset on the winter solstice. Builders without metal tools, writing, or reels positioned massive stones with enough precision to mark the two most important turning points in the solar year. This structure functioned as a giant seasonal marker, proof of sky-based timekeeping growing more advanced long before formal calendars appeared on paper. Biological rhythm played a role too, often overlooked in popular explanations of ancient timekeeping. Human bodies run on internal cycles tied to sunlight exposure affecting sleep, hunger, and energy levels throughout each day. Early humans lived close to these natural rhythms without artificial light disrupting sleep patterns, meaning their bodies reinforced the external clues found in the sky and land. Counting systems tied everything together into something close to a working calendar. Groups tracked days between key events using knots, notches, pebbles, or simple finger counting. This system allowed communities to plan hunts weeks in advance, coordinate meetings between separate bands, and track pregnancy length among group members. None of this required written numbers, only a consistent method agreed upon within the group. This kind of system never fully disappeared. Aboriginal Australian communities still use detailed seasonal calendars built on plant flowering, animal breeding cycles, and star positions, some tracking 6 or more distinct seasons across a single year rather than the four most modern calendars use. The San people of southern Africa, living close to the same region where the Lebombo bone turned up, built hunting schedules around detailed knowledge of moon phases and animal behavior passed down across countless generations. These living traditions show the ancient system described here was no rough guess. This system worked well enough to guide entire communities for tens of thousands of years, and versions of this same knowledge guide hunting and gathering decisions today. Agricultural timing eventually pushed this system further once farming communities emerged. Farmers needed precise seasonal timing for planting and harvest, pushing early societies toward more formal calendar systems built on solar and lunar cycles combined. Early farming settlements in Mesopotamia, dating back roughly 6,000 years, produced some of the first written calendars, dividing the year into 12 lunar months and adding extra days to stay aligned with the solar year. This shift eventually led toward the structured calendar systems still used today, closing a gap built over tens of thousands of years of informal skywatching. So here's the full picture. Early humans built an entire timekeeping system without clocks, without written numbers, and without a single centralized authority managing the process. Survival depended on reading the sun, moon, stars, and seasons correctly and passing this knowledge forward through direct teaching rather than written record. The system worked because consistency and shared understanding mattered more than perfect precision. This story reveals something bigger about human evolution. Our ancestors solved complex problems using observation, memory, and cooperation long before technology offered any shortcut. The same brain built this early calendar system now checks a phone screen for the date, proving human intelligence adapts tools to fit available resources rather than waiting for better ones to appear. Every notch on a 20,000-year-old bone represents the same drive behind a modern calendar app and need to know where you stand in time. Strip away the phones, the satellites, and the printed calendars, and the same question remains at the center of both worlds. What day is this, and what does this day demand from me? Would you survive a single year using only the sky as your calendar? Drop your answer below and let me know which method surprised you most. Subscribe for the next closer look into how early humans solved problems we take for granted today.